think one of the barriers is the regulation, is to have to go through the FDA approval and other relevant approvals. And the current approval standard is based upon the traditional way, where we have to have a fixed product. But the beauty of AI is it can keep learning. But I think the FDA is doing a good job. The new initiatives like the pre-certification program will help AI companies to be certified and keep certified as long as there's no problem happening. So that will enable AI to continue learning after it's been cleared.
Yeah, I think one of the key challenges to implement machine learning in radiology is getting access to high quality data. A lot of the data is not connected in healthcare, so understanding how to get the outcomes and other information about patients is very important.
A big barrier we see is that people ask, what is the benefit of this? I think there is a lot of hype here, and people are very excited about the space, but then they question, how does it meet my workflow? How does it meet the real world? And what do I get out of this? And I think the answer is you have to do research, right? We're in the medical space. You have to do science, you have to do research, and validate those outcomes, not just the accuracy of the solution, but what are the overall patient outcomes. And I think the more us as an ecosystem of AI can do that, the more benefit we can bring to the patient population.
Well, the biggest challenge obviously is usually the data. Data is the blood that flows through our system, and acquiring and curating data is always the biggest challenge. As a startup company and as a company in artificial intelligence, we need to make sure that we're finding great data sets from around the world that allow a broad demographics of patients, which allows us to create a very robust algorithm. But collecting the data is just the first step. Once you collect the data, you actually have to go through the process of curating the data. That means weeding the good data from the bad, bringing in radiologists to ground truth and annotate that data, and making sure that your true cancers are actually cancers, your true normals are actually normals, and that you've collected all of the associated clinical data to back that up and validate it along the way.
Absolutely. We hear from our customers a lot that they're very concerned with shadow IT popping up all over the place. And so we end up having conversations about how to provide AI infrastructure as a service. So basically what really that ends up being is research as a service. So we have a product that we've teamed up with NVIDIA to provide called AIRI, which stands for AI-Ready Infrastructure, that can fulfill that role very, very well. So in that way, organizations can stand that up, which is essentially AI in a box. It has NVIDIA GPU compute, it has our Pure Storage Flash Blade, which is an all-flash, scale-out, extremely parallel storage platform that supports file and object protocols, as well as 100 gigabit per second networking to tie it all together. So doing this, as well as including a curated software stack to do deep learning, we take all that guesswork and preparation out of the equation, thereby allowing researchers to start doing their job very quickly without wasting time doing IT-related tasks that they really don't want to be doing. So they can just bring their data, obviously that's very important, bring their curated and annotated data, labeled data, and then they can just spin up a model and train it, without having to reinvent the wheel.
I really think it's who's creating the data sets and deciding on the projects. So one of the things we need to do is get radiologists involved on the ground level. They have access to the data, they know the difference between an easy and a hard problem, and they know the difference between a trivial and an important problem. So we'd like to see more people at the radiology level creating the data sets, annotating them, and then using simple models to train them.
One of the key barriers is the need for extensive cybersecurity. When you start moving these files around between the practice and AI servers, we need to make sure that the security is well controlled, that you have an infrastructure in place that makes sure that there's no leakage of personal health, protected health information, and that everything is auditable.
Sure. When we were building our artificial intelligence algorithms, we quickly learned that it's very important to have large volume, but not just volume, also diversity of data. So making sure that we were building our algorithms with a sample of images from various data sources became very important to us. So we leveraged many different partners around the world that came and helped us collect data, collect annotations, and build algorithms.
I think we've been quite lucky in the sense that we collaborated with quite a few institutions in developing our first radiomics products. And so all of those people that were in that collaboration have onboarded very rapidly. What is more difficult is in faraway regions, and to make sure that those people get onboarded as well and adopt the products. The way we're overcoming this is to put them in contact with our current customers so that they can share their experience.
I think the big barrier is the deployment problem. How do you actually get the technology into the hands of practicing radiologists so they can use it in a clinical setting? We've been working with channel partners to solve the problem of how do you integrate with the PACS so that the AI analysis is available to the radiologist at the time of reading, rather than asking them to do extra tasks such as ordering analysis themselves manually.